A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened, while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, academicians, government agencies, consultants, and constructors to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previews for ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy and we look forward at the conference.
The Civil Engineering Study Program, University of Mataram, was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. Civil Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Semarang. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMYF Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the Government of the Republic of Indonesia through the Ministry of State-Owned Enterprises or BUMN as shareholder. ADI's status as a limited liability company encourages ADI to continue to provide the best for every stakeholder during the development of ADI and the growing construction industry in Indonesia. The intensity of competition and price wars between the construction industries has made the company redefine its vision and mission. PT Waskita Karya Tbk, a state-controlled company, is an Indonesian general contractor engaged in a wide range of construction activities including highways, bridges, buildings, facilities. PT Wijaya Karya Rekayasa Konstruksi or Wikarekon is a subsidiary of PT Wijaya Karya Persero Tbk or Wika, which is designed to be an integrated, aggressive, innovative, and professional company.
A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened, while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, government agencies, consultants, and constructors to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previous four ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy and we look forward at the conference.
The Civil Engineering Study Program, University of Mataram, was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. Civil Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Semarang. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the government of the Republic of Indonesia through the Ministry of State-Owned Enterprises or BUMN as shareholder. ADI's status as a limited liability company encourages ADI to continue to provide the best for every stakeholder during the development of ADI and the growing construction industry in Indonesia. The intensity of competition and price wars between the construction industries has made the company redefine its vision and mission. PT Waskita Karya Tbk, a state-controlled company, is an Indonesian general contractor engaged in a wide range of construction activities including highways, bridges, buildings, facilities. PT Wijaya Karya Rekayasa Konstruksi or Wikarekon is a subsidiary of PT Wijaya Karya Persero Tbk or Wika, which is designed to be an integrated, aggressive, innovative, and professional company.
Good morning, dear participants and speakers. Before the conference begins, I would like to give some information to you regarding the event rules in this two-day conference. The plenary sessions will start on time, so please bear in mind about this. And second, the participant ID in this event must use real name, not device name or institution name. Once again, the participant ID in this event real name, not device name nor institution name. To make it easier for the committee, please follow the name format as follows. For participant who is also acting as presenter, you should give the name with your ID paper and then dash followed by your name. Again, if you are presenters as well as participant, you should label your Zoom name ID dash and then your name, as you can see in the screen right now. And then if you are just as participant, you should write your institution, name of your institution, and then followed with your name. If you are keynote speaker, please write KS dash, then your name. If you are invited speaker, please write IS and then dash your name. If you are moderator, please write MD dash your name. And if you are the members of the committee, please write OC and then your name. The participants who join to this Zoom meeting should dress modestly and behave politely during the event. Participants are strongly encouraged to mute the speaker during the running of the events at all times. The duration for keynote speech is 35 minutes for the presentation, and then followed by a 15-minute discussion. So the total number of the total amount of time is 50 minutes per keynote speaker. And how to ask questions or make comments is during the presentation, questions can be asked through question and answer session. And you can write in the chat room on the chat box, and please write it in English. And then write your name as well. So the format could be your name and then your question, and then maybe I think it's enough. It's writing your name and then followed with your question. And then the keynote speaker will answer question and answer session. Once again, I would like to address good morning, ladies and gentlemen. How are you? Hopefully you are all in good health and condition. Keep your health, stay healthy. Okay, so hopefully you are in good health and condition to join the two-day conference today and tomorrow. I would like to present some information again regarding the event rules for this two-day conference. As you can also see in the screen right now, that the plenary session will start on time. This conference today will begin exactly at 8:30. And then the participant ID in this event must use real name, not device name nor institution name. To make it easier for the committee and also for the other participants to identify, please follow the name format as follows. If you are presenter, please write your ID paper and then your name. And if you are just as participant, please write your institution and then your name. If you are keynote speaker, please write KS and then your name. If you are invited speaker, please write IS and then your name. If you are moderator, please write MD and then your name. And if you are the member of the committee, please write OC and then your name. All participants who join to this Zoom meeting must dress modestly and behave politely during the event. Participants are strongly encouraged to mute the speaker during the running of the events at all times, except when you are maybe appointed to give your opinion or something. Okay, this is an exceptional time. The duration for keynote speech is 35 minutes for the presentation, and then followed by a 15-minute discussion. So the total amount of the time is 50 minutes per keynote speakers. The way how to ask questions or to make comments is as follows. During the presentation, questions can be asked through question and answer session. And then the keynote speakers will try to answer in the question and answer session. Just joined to this meeting today. If you haven't changed your ID when joining this conference, please change your participant ID as follows. If you are a presenter, please write your ID paper and then your name. If you are just participant, please write your institution and then your name. If you are keynote speaker, please write KS and then your name. If you are invited speaker, please write IS and then your name. If you are the moderator, please write MD and then your name. And if you are committee, please write OC and then your name. Thank you. Ladies and gentlemen, the fifth International Conference on Rehabilitation and Maintenance in Civil Engineering, bearing the theme Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering, is organized by the Department of Civil Engineering of Faculty of Engineering of Universitas 11 Maret Surakarta in collaboration with the Department of Civil Engineering of Faculty of Engineering of Mataram University. It's about 5 minutes to begin this conference. So, ladies and gentlemen, again, if you have not changed your ID, please follow the change of your ID as you can see from the screen. Ladies and gentlemen, in a few minutes, the two-day conference will begin. But again, I would like to remind the participants who might have just joined this conference, if you have not changed your ID, please change your ID as you can see from the screen. This fifth international conference on rehabilitation and maintenance in civil engineering, which has the theme Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering, is organized by the Department of Civil Engineering, a Faculty of Engineering UNS, Universitas 11 Maret Surakarta, in collaboration with the Department of Civil Engineering, a Faculty of Engineering, Universitas Mataram. This conference will last from today until tomorrow, the 8th and 9th of July, 2021. The fifth International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering, Solo, Indonesia, 8th and 9th of July 2021. Ladies and gentlemen, I am Yusuf Kurniawan, an appointed MC for this conference. To mark the beginning of the opening ceremony, we will listen to the national anthem of the Republic of Indonesia, Indonesia Raya. the Honorable Rector of Universitas 11 Maret, Rector of Universitas Mataram, Chairman of the Conference, Chairman of Agencies, Deans of Faculties in UNS. The keynote speakers, Professor Xin Jian Wang from National Taiwan University, Professor Buntara Eskan, Nihon University, Japan, Professor Edgar Bonner from Technical Research Center of Finland, Professor Muhammad Shahin from Geotechnical Engineering, Curtin University, Australia, Budi Yulianto, PhD, from Civil Engineering Faculty of Engineering, 11 Maret University, and Yusron Saadi, PhD, from Civil Engineering of Mataram University. The honorable invited speakers, distinguished guests, and participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning and welcome to the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering. This 5th conference bears the theme, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering, held in Solo, Indonesia, on the 8th and 9th of July 2021. This conference is organized by the Department of Civil Engineering of Engineering Faculty of UNS in collaboration with the Department of Civil Engineering and Engineering Faculty of Universitas Mataram in cooperation with Hiroshima University, Japan, Nihon University, Japan, University of Stuttgart, Germany, TU Delft, University of Technology, the Netherlands, Himpunan Ahli Konstruksi Indonesia, National Center for Research on Earthquake Engineering, Himpunan Ahli Teknik Tanah Indonesia, Universitas Diponegoro, Universitas Pembangunan Nasional Veteran Jawa Timur, Universitas Jember, Universitas Jenderal Sudirman, and Universitas Muhammadiyah Yogyakarta. Is sponsored by PT Hutama Karya, PT Adi Karya, PT Waskita, PT Wijaya Karya, PT Wika Rekayasa Konstruksi, and Sipilpedia. On behalf of the committee, I would like to extend my warmest welcome to all of you on this two-day conference. It is my great honor to preside over the opening of the conference. Ladies and gentlemen, let's get started. The first speech will be delivered by the chairman of the committee, Dr. Engineer Halwan Alvisa Saifullah, is going to deliver a welcome speech. Please welcome Dr. Halwan. The stage is yours.
Respected Rector of 11 Maret University, Rector of Mataram University, Dean of Engineering Faculty and Civil Engineering Department, Head of Civil Engineering Department of 11 Maret University, Diponegoro University, Muhammadiyah University of Yogyakarta, Jenderal Sudirman University, University of Jember, UPN Veteran East Java, PT Hutama Karya, PT Adikarya, PT Waskita Karya, PT Wijaya Karya, and PT Bika Rekayasa Konstruksi. Ladies and gentlemen, I'm welcoming you to this conference, the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering. This conference is organized by Civil Engineering Department of 11 Maret University in collaboration with other university and institution partners. They are Nihon University, University of Stuttgart, National Taiwan University, TU Delft, Hiroshima University, Diponegoro University, Muhammadiyah University of Yogyakarta, Jenderal Sudirman University, University of Jember, UPN Veteran East Java, National Center for Research on Earthquake Engineering or Himpunan Ahli Konstruksi Indonesia or HAKI, Himpunan Ahli Teknik Tanah Indonesia or HATI. This triennial conference has been successfully held since 2009, providing a forum for researchers, academicians, government agencies, constructors, and consultants to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance in civil engineering. This conference was initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to escalating COVID-19 outbreak and the need for physical distancing, we finally decided to shift the conference online. This year's conference adopts the theme Advanced Research on Technology for Rehabilitation and Maintenance in Civil Engineering. After peer review process, more than 100 papers were accepted for presentation at the 5th ICRMCE. The presenters who joined the conference are from Japan, Singapore, Malaysia, China, Taiwan, England, Kuwait, and Indonesia. We also have some keynote or invited speakers. They are Professor Xi Jian Huang from National Taiwan University, Professor Buntara Stanley Gunn of Nihon University, Dr. Edgar Bohner of VTT, Technical Research Center of Finland, Professor Mohamed Sahin of Curtin University, Dr. Budi Yulianto of 11 Maret University, Dr. Yusron Saadi of Mataram University, Professor Agus Setio Mutohar of Muhammadiyah University of Yogyakarta, Professor Suharyanto of Diponegoro University, Dr. Hosilang of Hiroshima University, Japan, Dr. Antin Hidayah of University of Jember, Professor Yining Ding of Dalian University of Technology, China, Dr. Nyoman Dita Putra of UPN Veteran East Java, Dr. Probo Hardini of Jenderal Sudirman University, Dr. Erwin Lim of Institut Teknologi Bandung, and Dr. Alfredo Satyanaga of Nazarbayev University, Kazakhstan. This conference will conclude with a short course on seismic evaluation and retrofit of buildings organized by NCRI Taiwan and 11 Maret University. In the process of organizing this conference, we received invaluable motivation, advice, and support from several individuals and institutions. I would like to express my gratitude and appreciation to all of them. Finally, on behalf of the organizing committee, I would like to apologize for any shortcomings that might happen during the entire event. Stay healthy and we look forward to the next ICRMCE.
Thank you, Dr. Helwan. The next welcome speech is going to be delivered by the Rector of Universitas Mataram, but on this occasion is going to be represented by the Vice Rector for Planning, Collaboration and Information System, Yusron Saadi, ST.MSc, PhD. Please welcome Pak Yusron to deliver your speech. The stage is yours now.
Thank you. Rector of the University of 11 Maret, rectors and deans of partner universities, distinguished guests, speakers, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I would like to express my warmest welcome to the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering. This international conference has been initiated by the University of 11 Maret, which enthusiastically invited the University of Mataram and several partners universities to join in. Therefore, allow me to express my deepest gratitude to the Rector of UNS and also to the rectors of partner universities involved in organizing this very exciting international conference. Rectors of UNS, rectors and deans of partner universities, distinguished guest speakers, participants, ladies and gentlemen. I am very proud to be here with expert researchers and academia from many countries, and it is truly an honor to be able to deliver my welcoming speech. This conference will provide an excellent opportunity for sharing knowledge in the field of smart and innovative technology for rehabilitation and maintenance of infrastructure in industrial era 4.0. Smart and innovative technology is of particularly important, especially because we are currently experiencing what is known as the COVID-19 pandemic. Conventional ways of repairing and maintaining infrastructure require new breakthrough. It should also be considered that Indonesia is a country that is very vulnerable to disaster because it is located in the ring of fire. Therefore, the planning of disaster-resistant infrastructures, repairing technique, and maintenance of existing structures should be an important concern. In the process of searching what we call a new normal, adequate effort of anticipation to natural hazard should also be in our priority. In this situation, the development and the application of smart and innovative technology are of particularly necessary. I noticed that the aim of the conference is to provide an environment for researchers to discuss the development of smart and innovative technology, particularly in the rehabilitation and maintenance of infrastructure. The presence of keynote speakers and invited speakers from various countries really enrich this conference. It can be expected that there will be an interesting exchange of information, especially in terms of scientific development and other technological innovation in the field of rehabilitation and maintenance of infrastructure. Rector of UNS, rectors and deans of partner universities, distinguished guest speakers, participants, ladies and gentlemen. The Industrial Revolution 4.0, marked by the continuous automation of traditional manufacturing and industrial practices using modern smart technology, requires expert in its implementation. Therefore, intense interest from participants who will be presenting papers on smart and innovative technology for rehabilitation and maintenance of infrastructure are clear signal that there will be a positive impact from this conference. It is also expected that the conference will create partnership between universities and industries in finding new technologies to finally configure the innovation at a larger scale. We have to take this exciting conference forward to make it beneficial in the development of smart and innovative technology for rehabilitation and maintenance of infrastructure. I do believe this event will generate discussion which can be transferred into real works, as in this modern era, there is a strong emphasis on putting theory into practice. I would like to express my sincere thanks and appreciation to the Rector of UNS, rectors and deans of partner universities, organizers of the conference, keynote speakers, invited speakers, and also to the sponsors who contribute to this event. To all participants who have joined from different countries, I would like to extend my very welcome to this conference. I wish you all have a productive and fruitful discussion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
The final remark is going to be presented by the Rector of Universitas 11 Maret Surakarta, but on this occasion, he is going to be represented by the Vice Rector of Research and Innovation, Professor Dr. Kuncoro Diharjo, STMT. Please welcome Prof. Kuncoro. The stage is yours now.
Thank you for the time. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen, Honorable Director of Mataram University, who represented by the Vice Rector of Planning, Collaboration and Information, Professor Yusron. Good morning, Prof. Yusron. Thank you for coming this morning. Honorable the Dean of Engineering Faculty and Head of Civil Department of 11 Maret University, Dr. Teh Solihin As'ad and Dr. Niken Silmi Sulanjari, and also the deans from Mataram University, Diponegoro University, Jenderal Sudirman University, UPN Veteran University, East Java, Jember University, and Muhammadiyah University of Yogyakarta. Honorable the Director of National Center for Research and Earthquake Engineering, ICRMCE from Taiwan. Honorable the Head of Himpunan Ahli Konstruksi Indonesia or HAKI and the Head of Himpunan Ahli Teknik Tanah Indonesia, HATI. Honorable keynote speakers, Professor Sheikh Jian Huang from National Taiwan University, Professor Bantara Stanley Gan from Nihon University, Professor Edgard Bohner from VTT Technical Research Center of Finland, and Professor Muhammad Shahin from Curtin University. Honorable the Chairman of this conference, Dr. Halwan Alvisa Saifullah, and Honorable all invited speakers and all participants. On behalf of 11 Maret University, I am pleased to welcome you all to the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering with ICRMCE, organized by the Civil Engineering Department of 11 University, Mataram University, and other partner universities. First, I would like to congratulate the organizing committee for successfully holding this international conference despite the restraints and challenges posed by the COVID-19 pandemic. This conference was initially planned to hold in Lombok. Therefore, plans changed to conduct a blended system conference. However, Due to the pandemic situation in Indonesia, we conclude that this conference will be held fully online. The dedication shown by the organizing committee has taught us that if there is a will, there is a way. Many thanks to the university partners that get involved in this event. They are University of Mataram as co-organizer, Diponegoro University, Muhammadiyah University of Yogyakarta, Jenderal Sudirman University, University of Jember, and UPN Veteran East Java University. Some institution partners, among others, Himpunan Ahli Konstruksi Indonesia, Himpunan Ahli Teknik Tanah Indonesia, and National Center for Research and Earthquake Engineering Taiwan have also given great support to this conference. Over the years, this conference has been conducted once in 3 years, and today marks the 5th occasion of this grand event. This conference has continued to show our university's commitment towards supporting the global sustainable development of building resilient infrastructure and fostering innovation by enhanced scientific research and upgraded technological capabilities. This year's conference adopts the theme Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering. And we hope that this conference serves a forum for researchers, for academicians, government agencies, consultants, and contractors to exchange experience, technological advancement, and innovation related to rehabilitation and maintenance in civil engineering. Furthermore, we hope this event strengthen the cooperation between 11 Maret University and other partner university locally and internationally. And moreover, for supporting the implementation of Campus Merdeka and World Class University Initiative. The Indonesian government initiative Campus Merdeka, which means independent campus, emphasizes the need for collaboration between universities, as well as building stronger relationship between universities and industries. As legal entity state university, UNS is expected to carry out institutional strengthening leading to achievement of key performance indicators. The activities that carried out by the departments, faculties, and the university must contribute to the achievement of the KPI. One of the KPI is that department collaborate with world-class partner in research and other activities fostering knowledge sharing. I am certain that this conference is in line with national and global goals, and I'm assuring you that we are open to facilitating more events like this event in the future. Once again, I would like to welcome you all to this virtual conference while expressing my heartfelt appreciation to the organizing committee, partner universities, sponsor, and our esteemed keynote invited speaker and all participants. I wish you all good in health. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Kunsoro, for delivering the speech.
So am I.
Ladies and gentlemen, in a moment, we are going to begin the keynote speech sessions. However, I would like to remind the committee to present the link of the attendance for today's conference on the chat room. And I would like also to remind the participants, if you have already seen the link of the virtual attendance, please fill them out. Okay, ladies and gentlemen, it's now time to have the keynote speech sessions. first keynote speech, which is going to be delivered by Professor Xin Jian Wang from National Taiwan University. Professor Dr. Sorry, that is the curriculum vitae of the moderator. Okay, well, I would like to give you information that for the first session will be chaired by Professor Buan Ansori. Now let me read the CVs of Prof. Buan. Professor Dr. Insinyur Buan Ansori, MSc, is from the Department of Civil Engineering, Faculty of Engineering of Universitas Mataram. He accomplished his bachelor in engineering department in Mataram University in 1996, and then he pursued in the University of Liverpool, the United Kingdom, accomplished in 2001. And then the PhD was obtained from University of Liverpool from the same country, United Kingdom, in 2013. Juan is coordinator of research center of Mataram University. He has in research in structural design elements. Now I would like to present the curriculum vitae of Prof. Xin Jian Wang. Professor Xin Jian Wang comes from the Department of Civil Engineering, National Taiwan University, Taipei, Taiwan. He obtained his bachelor degree in civil National Taiwan University in 1979. And then he pursued the master's degree and obtained his master's degree in the same field of study, civil engineering, from University of California at Berkeley, USA in 1982. And then he accomplished his PhD in 1989 in civil engineering from the same university, University of California at Berkeley, USA. Since 2006 until now, Prof. Buan is teaching at the Department of Civil Engineering, National Taiwan University in Taipei, Taiwan. And then 2017 until 2021, he is the director of General National Center for Research on Earthquake Engineering in Taipei, Taiwan. And then from 2013 until 2017, he was the Deputy Director of National Center for Research on Earthquake Engineering in Taipei, Taiwan. Okay, well, ladies and gentlemen, now let me invite Prof. Buan Ansori to chair today's keynote speech. Please. This session lasts until 9:50.
Thank you, MC. We are going directly to Professor Huang, about 35 minutes to present. Already introduced by MC. I think already know what's the background of Professor Huang. So, Professor Huang, stage is yours.
Okay, thank you for Chairman's kind introduction. So my name is Jian Huang. So as we all know that our nation right now is have a big trouble with the COVID-19 pandemic. So I would like to show my deep sympathy for the people who are seriously affected by this disease. So hopefully all the participants that everyone and your family will be safe. So then I would like to show my appreciation for the organizing committee to invite me as a keynote speaker. So it's a great honor of me. So today I would like to talk about the smart retrofitting of the RC structure, specifically where we are dealing with the self-joining compression brace. So before my introduction, I would like to show ICRMCE. So I'm the past director of ICRMCE, and the ICRMCE is the National Center for Research on Earthquake Engineering, and was established in 1990 in the National Taiwan University. Our mission is for the disaster prevention, reduction, and relief. So we have two very big laboratory, one in Taipei and another in Tainan. And our headquarters is right now in Taipei. So as you can see from this picture, so whenever you have the chance to visit Taipei, please let us know. Let us show you what we have. So today, my presentation will separate into 6 parts. First, I will talk about the background knowledge and introduce the device I talk about. And the special characteristic is that we try to avoid the failure of the adjacent member. And then this retrofitting device, the strength should cope with the existing structure, and therefore they can have a good combination of the two. Then we have test verification, and then I will draw my conclusion. So let me start with the introduction. Since right now I'm the only one in this room, let me take out my face mask. So in Taiwan, as always other countries, you can see from the earthquake reconnaissance, if we have the non-ductile detailing of the vertical member, they are quite vulnerable. And therefore for the short column, for the typical column, as well as the shear wall, they have failure during the earthquake. That's indicate insufficient seismic capacity of our vertical member. In Taiwan, we have another problem, is that since our land is limited and our population density is very high, and therefore for the city planning, we adopt the mixed use building. It means that a building in the lower story is a commercial purpose. So they need the open space. Therefore, the vertical member is a smaller as better. And but for the upper story is residential purpose. So we have a lot of partitions. So in this case, we create the soft first story. So during the earthquake in Taiwan, 2016, the Richter scale 6.3, and we have a complete collapse for this soft first story building. So for this kind of building, first is an older reinforced concrete building. In that time, they don't have the seismic code protection. Therefore, they result in non-ductile member. And the second, they have the top and the weak story. So we need to retrofit them. In Taiwan, we use a lot of technology, such as the jacket column, and we can put the shear wall within the frame, or we can have a wing wall. Wing wall like this is a small piece of wall aside the column. So that's a very effective retrofitting method. But they have problem because we call that as a rat, retrofitting method. So they need to chip off the concrete cover and put in the reinforcement cage and then cast the concrete later. So for this kind of construction procedure, first we have noise, right? And the second, we have dust. And the third, most important, we have to relocate the rest. So this can be done in school building because we have summer vacation, but for residential building, it causes a very serious problem, for this kind of the drawbacks. So in ICRMCE, we start to research, can we use the steel frame with the brace and the retrofit outside the building, and it helps to improve the capacity. So from the year 2013, we start with the steel frame plus brace. And then we come out, we change the concept. And you can see from here, why? Because if we use the steel frame and with brace, first, you have to do the rebar planting. And that's a black one here. And then you insert the steel frame with the brace, but using the shear stud. And then we cast the motor, to connect them. So it's a procedure, quite tedious, and still you need the casting. And why we want to have the multicasting? Because we want to distribute the force more evenly and not concentrate on a single part of our existing frame. But test results indicate still insufficient. You can see on the right part, we have a RC frame retrofitting using this methodology. And you can see that the failure of the adjacent frame is very serious. That's due to the tension. And then another problem is that the retrofitting, seems too stiff. It means that we are using the brace. The brace has a very large capacity compared with the existing one, but they occur the peak value around 0.7%. And then maybe the brace, they have compression buckling and combined with deterioration of the RC frame. So it turned out to be very brittle. And then the problem is that for the existing RC frame, it's very soft. And the maximum strength usually occur at the interstroke drift about 2%. So this kind of two elements, they cannot add together. So non-additivity of the existing RC frame, we consider that's a really huge drawback. And here the photo show that during the test, you do have a problem of the buckling of the brace. And then if you use a BRB, and that's a buckling restraint brace, and of course, subject to tension and the compression, you have a very good symmetry behavior. But the tension developed by BRB will introduce to the RC frame, and it still cause the tensile failure of the RC frame. For this case, is the pull out of the anchor bolt. So we have to remember that RC, the concrete tensile strength, is comparable weak than the compressive strength. So if we can avoid using the tensile strength of the RC frame, that will be better. So we are thinking how to solve the dilemma that we have. So maybe we can use the precast brace and the self-joining device, and that can speed up construction procedure. So it should be a faster and a dry type. And then the failure of the adjacent member should be avoided. So maybe we introduce only the compression instead of tension to the RC frame. And then we hope that the retrofitting device, their strength can combine with the existing structure. So therefore, using buckling restraint brace, they have very ductile behavior, and therefore we can combine the strengths together. So that's the idea we have. Then we develop the technology as I would like to speak today. So let me introduce the self-joining device for compression only. So that is a very clever invention starting from Japan, from the Kyoto University, with Professor Watanabe and his research team. So you can see that they use the precast brace, and whenever earthquake loading come, and then for the red rectangle, so it's a compression force, but the compression force can be transferred to the structure. But in the other end, the blue rectangular, and subject to tensile elongation. But due to the spring, the tensile force cannot transfer to the RC frame. So that's the idea that we are dealing with. Let me show that more in detail. So whenever you have a compressive force, the compressive force from the brace, they will contact with the tube of that device, and therefore the compression force can be transferred to the concrete. But if you have a tensile elongation and the spring, can have a tensile less stretch, and therefore they still hold the device in position, but the tensile force cannot transfer, to the concrete. So that's a very important concept. So based on the device in here, so we try to develop associate technology. Let me discuss about the failure prevention of the adjacent member. So this figure seems a little bit complex, but let me start a little bit more in detail. So this figure indicates the BRB force in the vertical axis, and the horizontal axis is the spring deformation for this part. You can see that whenever they contact, so there is a turning point. So once they contact and the compression will introduce a very large force from the BRB to the structure. But when they separate, then the spring stiffness will control. So it's very soft. And for these two parts, in the stiff part, we have to design the maximum BRB design force. So once we control this force, and then the failure of the adjacent member can be avoided. But another point is that for the soft section, so the BRB should hold in position. It depends on what? Depends on the spring. The spring should have a pre-stress force. And therefore, at this point, the spring still can hold the weight of the BRB and everything in position. So it's a minimum pre-stress force of the spring is required to preventing the falling of the BRB. So for these two design, point I will explain. First, let's talk about how to prevent, the failure in the adjacent member. So whenever you have an earthquake force introduced to here in the compression, you can see that will transfer, to the frame. They are like the shaded, the blue area here. So let's try to avoid the failure occur in the neighborhood. So we can see more in detail. So what kind of element involved? So whenever the compression force from the BRB, so we have three elements. First, for the beam part, it looks like a cobell. So whenever the force transfer, the cobell part of the beam should be in safe. And another one is the column, and also like a cobell, but in between is a beam column joint. So let's try to calculate the shear strength and avoid the associated failure. So how to do that? So it come back, we have a series, and that series, first we try to find out what's the wall type element. So let me use cobell for explanation. Here is a cobell. Wherever you have a compression force, you will introduce inclined shear crack. But within the shear crack, you introduce the compression force. That's we call compressive strut. But at end, at end of the strut, the concrete crush. The similar behavior can be seen for beam column joint. So you have compression zone on the left upper part, and in the lower right part, also compression zone. So within two compression zone, you have a diagonal force transfer. At end, also concrete crush. So we see that similar phenomenon also occur in the deep beam and the squat wall. So they have similar load pass. They have a similar failure pattern. So the prediction, should be unified. So that's the background we start with, and we develop the softened strut and time model. So as can be seen on the left part, that's a beam column joint. So within the joint, you can see a big diagonal stress fault. But the mechanism inside, they have to satisfy the Navi principle. First, should be equilibrium. Second, they should follow compatibility rule. And then all the material, they should follow the constitutive regulation. And then eventually, the failure criteria as the concrete crushing. So let me explain more in detail. So as can be seen in the beam column joint subject to earthquake loading, so you have compression zone in this part, and opposite another compression zone. And in between, you have the diagonal stress flow. And then how to check the equilibrium? Since your stress is highly disturbed, so we cannot use the point equilibrium of the stress to check equilibrium. So we have to use strut and tie. And therefore, you have concrete strut as a dashed line, and you also have the tension tie as a horizontal shear reinforcement as a horizontal tie, and the vertical shear reinforcement as a vertical tie. And the equilibrium should be held for this region. And the second, for compatibility, you can see that within this region, you have a strength field, and you have a horizontal strength, vertical strength, and you also have the diagonal strength and the strength perpendicular to the crack. And they should follow the more compatibility as the equation showed in here. And then for constitutive, and we can use, for the tension time, we use elastic perfect plastic behavior. But for concrete, we should use more sophisticated and advanced idea that we call softening. So then if you follow this constitutive, and then let me show you. And the failure mechanism should be the diagonal compression value in here. So that's the procedure that we are using. This procedure can be applied in here. And why? Because we check so many specimens. So you can see that, let me use a cobalt as an example. So we have a 178 cobalt, and use the vertical axis should be the test strength of the cobalt divided by the theoretical prediction. And wherever you have a value equal to 1, it means accurate. And if you have a value greater than 1, it means our model is conservative. So for all the cobalt is spread out with the normal strength concrete in here, and also with a high strength concrete in here, but it's very consistent. So the strength ratio is about 1.21, and the coefficient of variation is about 0.17. And all other elements, they have similar average and a similar coefficient of variation. So for the beam current joint, we have the exterior beam current joint and the interior beam current joint. So we believe this theory can be applied, to the technology we are talking about. Then how to use that? So let's use this figure. So wherever you have a BRB, you will transfer diagonal force into the frame. But the vertical component we call PB, and the vertical force will transfer, by the beam part. So it looks like a cobalt. So whenever the force transferring here, the beam cobalt should have enough strength. It means that the vertical component of the BRB with the sine theta, this value should less than the diagonal strength of your cobalt and also the sine component. And therefore, this equation can govern the magnitude of the PB they can have. And similarly, for the column cobalt, it depends on the horizontal component from the PBRB. And it should be less than the cobalt diagonal strength with the cosine component. And then the beam current joint, and we have to study more in detail. So then the diagonal force from the BRB create an opening moment for the beam current joint. And therefore, we can check in this way. The vertical component PB will introduce a clockwise moment here. And this moment will create a horizontal compression force. And this horizontal compression force will transfer to the beam current joint, should be resisted by the diagonal strut and with the cosine component. And then we can establish the equation to describe the relationship. And also for the horizontal component of the PBRB, you will introduce the counterclockwise moment, and you have a vertical compression passing to the beam current joint. And therefore, your diagonal strength with the sine component, they should resist this kind of force. So based on the idea in here, so we can use this figure to make a brief summary. So the force of the BRB, the strength, you should choose from the beam, from the column, from the beam current joint. And then if the value less than their strength, and it guarantee the strength can keep safe during the retrofitting procedure. So for design, it's better to use a strength reduction factor to make it safer. So let me talk about the additivity of the BRB and how to do that. So as I criticized in the beginning stage of the anchor research, so we are using the steel frame with the brace. It turned out that non-additivity. And the first is the buckling of the steel brace. And the second is the tension failure around the RC frame. And the most important is that all the retrofitting behavior seem too brittle, and therefore no cooperation between the steel brace and the RC frame. So try to overcome, and we are thinking maybe we can use the BRB and combine with the self joining device. So let's check it. So in the Anchor laboratory, so we have a BRB fabricated like this, and we also have the self-joining device like this, and then we hold it together and put underneath the 500-ton universal testing machine, and then the test result like this. So whenever you have compression, so the compression capacity maintained tend to a very large drift in this way. But whenever you introduce tension, no problem. The self-joining device will absorb the elongation, but no tension force, right? So then I think this idea, can be realized. And then we fabricate. We think that, okay, we kind of achieve, our original thought about the faster and the dry type retrofitting, and the failure prevention can be done, and the additivity can be helped. So then how to make sure that the additivity can occur? It means that you have to put this device in position always, right? So whenever you have an earthquake sway of your frame, and this brace should hold in position, even they have tensile elongation. So we are now checking this range, for the softened part. So design item first, what's the stroke of your tensile elongation should be determined. And then what's the minimum pre-stress force of the PFAX in here? So these two items, let me explain. First, so we think that for this curve I introduced before, so the horizontal axis is the spring, deformation. And the spring deformation, that it means that we have the delta fix. It means if you want to hold, the BRB, the force you must have and associate with the elongation, compressive. And then during the tensile, elongation, the delta target in this part, you should be designed for the spring. Otherwise, they will fall out. And then even they contact, the spring will move a little bit, just like this. That's a delta 2. So delta fix, delta target, and delta 2 added together. And then you should have your spring, your free length, should larger than that. It means that you should have a stroke. In here, the number of the stroke should larger than the summation of these three values. And then how to design the delta target? The delta target, we can see it this way. If we push the frame to the right, and our BRB is subject to compression, and then we have to calculate what's the elongation they have. So it looks like this way. If you push and you reach the strength into the inelastic range, but the compressive deformation here can be calculated using the design drift 2% times the height of your frame, and then using the cosine component as that actual deformation. But whenever you change the earthquake force to here, you have to remember, your BRB will come from here, but you do have a residual deformation during the compressive stage, and then they move, to the tensile one. So you can see that for delta target, you need to, include the residual strength in the compression, and also the tensile elongation for the spring. So then how to design the delta target? So then we use this formula. That's a 2% and of the HN and the cosine theta. It means we use a factor of 2. The 2 means 1 for the compression and the 1 for the tension. But we add another safety factor, alpha 0. That's 1.5. And then we design the delta target, and the rest is simple. And then for P fix, we are choosing the design equation like this. The weight of the BRB, we use a factor of safety 3, because in earthquake, that's a dynamic behavior. So don't use 1. We have to increase, for some safety. And then you can calculate based on the stiffness of your spring, and you can determine, your delta fix. So for the idea here, we do have the test specification. So in Anchorage, we perform the test, look like this way. So we put the BRB with the safety joint device in both ways, because we want to save, the testing. So you can see that here is about the 1/2 scale, and then the RC frame with the slab in the beam. But the strength is a normal strength concrete, and we test in this way. So you can see that during the construction, we have the BRB with a self-joining device, but it can be easily handled. by manpower. And to establish, one BRB, the device, less than 1 hour. And it should be remembered, this is transportability. So you can retrofit in one location. But if you necessary to move to other location, it's no problem. Simply take it out and shift to other location. So that's a big merit for this retrofitting method. So that is the construction stage in the Anchorage backyard. And then we put in the mass system in Anchorage. So this is a huge testing facility. They can introduce the vertical load and the earthquake horizontal load. They can use the actuator here. So they can input about the 400-ton lateral force. And the vertical force, this one, we can input about 6,000 tons. So, but not for this test. So that's a schematic, layout like this way. So the testing specimen put in here, and we put our measuring device. And we have to compare with the retrofit one. So that's the prototype. The prototype test belong to the Ube. That's a company in Japan. So they have the testing cooperation, in Anchorage. So the test result can be found in the Ube report. But we didn't repeat. We simply use their frame, for comparison. And then we introduce a similar frame and with a retrofitting device as we have. And here is the test result. And if we combine these two, you can see that and retrofit one is improved. And the retrofitting specimen is in black. And the strength almost double. And the more important is the retrofitting one, the elongation, the drift displacement, they stop in here. But for retrofitting one, they can go farther, so more ductile. So I think that's an advantage, for this testing one. And then we check more closely about the major force in the BRB. So you can see that for the blue BRB in the positive direction, so that's a major force. But whenever they change direction in the negative direction, the blue BRB, they don't introduce any tension. But on the contrary, the red BRB, they can introduce the compression in the other direction. But they introduce no tensile force, in the positive direction. So I think that idea, can be, fully, test through this research. And I will share it with you. That's a measurement. Indeed, the BRB in compression, and we push the BRB to the nonlinear stage, and therefore the residual, deformation should be included in this design. This should be emphasized. It's a very important concept. So then I would like to draw my conclusion is that in Anchorage, we would like to have a faster and dry type. Also, the retrofitting can relocatable. So in this idea, we introduce the prefabricated brace, the BRB, with the self-joining device. And then we want to avoid the failure of the adjacent member. So the existing frame, we don't have to retrofit that. We simply add a device, and that will make everything simpler. So in this demand, the brace can introduce only the compression to use the compressive strength of the concrete. That's much reliable, if you want to use the tensile strength. And then we use the buckling restraint brace because they can have a very good, deformability, ductile behavior, and therefore the brace capacity, can combine with the existing frame. So that's additivity. That's always plus. We have to use the existing strength. We don't throw that away. And then all the retrofitting, we just added more. So I think that's a more economical way to do things. So I think that's all my presentation today. And thank you for your attention. Yeah. So is there any question? Yeah.
Okay, thank you, Professor Huang, for delivering a very interesting about novel ways to retrofitting of reinforced concrete. Now we go on to question and answer session. We have time about 15 minutes for this session. In the room chat, there is some question. The first one from Ferry Hermawan. The question is about, does the retrofit effort equal to economic aspect? How much in proportion cost between actual cost of retrofit compared with whole part of construction during post-engineering by experience? Thank you. This is the first question.
Okay. Yeah, it's a very good question. So we are not introduced to the practice in Taiwan yet, but in the laboratory experience is that whenever we want to build a retrofit in an RC column, it's about about $100,000 NT. Then using this device is about a similar amount of money. So it means that if you retrofit a column, you can buy this device already. Is that answer your question?
Yes, I think Mr. Ferry Hermawan, it's answered your question. Okay, the next question from Isiana. What condition must be met in placing BRB in the structure? Maybe it can be related to the length of the span of structure, or maybe something else.
Pardon, you say that the BRB, if we choose the BRB, do we need to pay special attention for the choice, or is that the question?
I mean, what structure, what kind of condition of structure can apply for this BRB?
Oh,
any structure or any frame?
Okay. So I think I understand your question now. It's very interesting. Original, we designed, this device. We are aimed at, the reinforced concrete, the low-rise building in Taiwan, because our old RC building, the compressive strength is very low, right? So it's around 20 megapascal. So then we cannot introduce, a very, huge retrofitting device. So it should be a smaller size, and then like I show you here. But as you can see, if we try to promote this technology to the intermediate or the high-rise building, is that possible? I think it is possible, because you have to make the BRB size bigger, and then your self-in device, the spring, should be special order, should be customized, and you cannot easily to get it, through the market. But for industry purpose, this kind of spring exists. So therefore, for this retrofitting method, I think that right now is being proved for the low-rise building with very weak, ICRMCE can be used. And for the long run, we hope we push this technology to the high-rise building in Taiwan as well. Yeah.
Okay, thank you for the answer. The next question from Mr. Muhammad. What is the connection system between the BRB device and the existing building like? What are the considerations for using this BRB in old building? Thank you.
Okay, so we choose to use the BRB because the BRB, they have a ductile behavior, and therefore they have a large drip. You still can maintain the strength, and therefore the strength can be added, to the existing RC structure. So that's a very important thing. And secondly, BRB, the compressive strength can be designed, right? Because we can choose what's the material for our brace, and then carefully calibrate, the maximum compressive strength of the BRB. So we have to control the strength, and then try to avoid the failure of the adjacent membrane. So that's our major, consideration to choose BRB in this retrofitting scheme.
Okay, thank you. The next from Mr. Erwin. The question is, in the existing old exterior reinforced concrete frame, usually the hook of beam and column longitudinal bars are bent outward, not inward in required current code. Is there any modification of concept need to apply this BRB?
Okay. Yeah. Hello, Erwin. Yeah. Long time no see. So I think that your question is very interesting. So let me put it in this way. So you can see that the test I showed that there is a failure in the column due to the shear failure. So therefore, indeed, our non-ductile column, they lack up the transfer reinforcement and therefore is vulnerable. But usually for this non-ductile column, they still have a flexibility. So therefore, they can have a drift about 2%, no problem. And for the low-rise building, our target is to increase the strength of the low-rise building. We are not trying, to enhance the ductility of the low-rise building, right? So if we can guarantee 2%, and it means that we add the strength, to the existing RC building, and maybe they can satisfy the safety, concern. But if this retrofitting method, move, to the maybe medium to high-rise building, we still want to have, very good ductile behavior. And then for the column, maybe we need to retrofit their ductility. So it's not too hard. We can use FRP, wrap the FRP, or using steel plate is also possible. So as long as the column or other vertical element, they do have deformability, and then we have to decide it, what kind of objective, the goal for this retrofitting, and then we have to solve. Maybe the problem is in a series, but still, that's an engineering problem, so we can solve it.
Well, for next question from Mr. Remir Joseph. Do you have future plans to develop other design of this BRB in order to meet different architectural requirements?
So I think that current this design approach, we are thinking that maybe we wanted to commercialize, and how to do that. First, maybe we have to design several type of the BRB with just like a reinforcement. They have several grade, and then for engineer, easy to pick it, and also for the spring, it's of special concern. So what kind of spring? And then this in the market, we still need to find out the suitable spring to be used. But I think for engineer to use, most important is that provide the analytical and the design tool. So in our next step, we will put in entry, using the on-demand service. So if they want to use this, and what's the requirement? Is a target drift, and what's the frame they have, and maybe we can provide the design for them, and to choose a suitable BRB and safety device in our bank. And in this way, we try to promote this technology in this way.
Well, thank you for complete answer. The next question from Prof. Agus Montohar. In using BRB, do you have experience what's the effect of the foundation system?
BRB for what?
The effect on foundation system.
I see. So okay. Avoid the failure introduce this, but there may be a problem that occur to the foundation. Yeah. So in the low-rise building current stage, we don't worry about that. Why? Because we are introduced the capacity not too large, and usually for foundation we have a ground beam, and we have a spread footing and contact with the soil. So it's very easy. The force can transfer, out. But if we have a very large, BRB capacity we use, then we have to check, maybe accumulate several BRB together, and then what's the foundation, capacity. I think this should put in the design, procedure to consider the foundation. Yeah.
Okay, thank you. In the room chat, I can already to answer. Yeah, the last one. Any specific material for BRB? Any just steel or something can be used?
Oh, okay. I think that in BRB, I think the tube is quite common, regular. But the interior, the brace, we can use the low yielding, steel. And then that's, of course, we have several selection using the low yielding or the high yielding as well. But the low yielding can make everything, much easier. And especially if the steel, the strength hardening, the lower the better. Yeah, because we have to add, safety factor, to control the strength hardening. But once the strength hardening become very severe, and then we have, of course, we have to increase, all the design consideration. That is not so economy. So if we can control, the brace to have a very steady yielding strength, I think that without very too much, hardening, that would be a good choice, to design the BRB.
Thank you. I think that's all question. Probably because 5 minutes left, I make wrap up this session. The topic what is interesting, introduce a fast and dry type troughing method with using BRB, buckling resistance brace, with safe joint device. It uses a spring inside the device to subject to tensile deformation of BRB, eliminating the tension force of the BRB, which acts on the adjacent plate for concrete member. Then the axial compression strength of the BRB is carefully selected to prevent causing damage of an adjacent for concrete member. In this way, due to the high ductility of the BRB, the lateral strength of BRB can be directly superimposed on the maximum lateral strength of the existing HC bearing. Moreover, the press force of spring inside the self-joint device can enable to BRB to be consolidated with the existing LC frame, reducing the construction work of interface anchoring. I think that's all the conclusion of this session. Thank you very much for presentation, for a nice presentation about smart retrofitting of concrete. So all audience give big applause to Professor Huang. Please.
Okay, thank you, for your attention. And also, I would like to thank Professor Anshari, your wonderful, conclusion for this speech. It's a great honor for me to speak in here, and I hope that everything get well, especially in this difficult time. And thank you very much.
Thank you. All right, at the end of the session, I return back to MC, Pak Yusuf.
All right.
Thank you very much, Prof. Wang and Prof. Ansari. Well, hopefully have delivered the thing would be fruitful and beneficial to the future. Okay, ladies and gentlemen, now we are having a break for about 15 minutes. You are cordially invited to enter the ballroom again to have our next keynote speech, which will start at about 10:05. Okay, now we are having a break for about 15 minutes. Thank you.
Civil Engineering Study Program, University of Mataram was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. Civil Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Samara. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the government of the Republic of Indonesia through the Ministry of State-Owned Enterprises or BUMN as shareholder. ADI's status as a limited liability company encourages ADI to continue to provide the best for every stakeholder during the development of ADI and the growing construction industry in Indonesia. The intensity of competition and price wars between the construction industries has made the company redefine its vision and mission. PT Waskita Karya Tbk, a state-controlled company, is an Indonesian general contractor engaged in a wide range of construction activities including highways, bridges, buildings, facilities. PT Wijaya Karya Rekayasa Konstruksi or Wikarekon is a subsidiary of PT Wijaya Karya Persero Tbk or Wika, which is designed to be an integrated, aggressive, innovative, and professional company.
A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened, while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, academicians, government agencies, consultant, and constructor to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previews for ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy and we look forward at the conference.
The Civil Engineering Study Program, University of Mataram, was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. Civil Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Semarang. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the government of the Republic of Indonesia through the Ministry of State-Owned Enterprises or BUMN as shareholder. ADI status as a limited liability company encourages ADI to continue to provide the best for every stakeholder during the development of ADI and the growing construction industry in Indonesia. The intensity of competition and price wars between the construction industries has made the company PT Waskita Karya Tbk, a state-controlled company, is an Indonesian general contractor engaged in a wide range of construction activities including highways, bridges, buildings, facilities. PT Wijaya Karya Rekayasa Konstruksi or Wikarekon is a subsidiary of PT Wijaya Karya Persero Tbk or Wika, which is designed to be an integrated, aggressive, innovative, and professional company.
A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened. while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, academicians, government agencies, consultants, and constructors to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previews for ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy, and we look forward at the conference.
The Civil Engineering Study Program, University of Mataram, was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated.
Dear participants, ladies and gentlemen, though the time is still minutes, but I think considering the remaining of the time, in order to be more efficient, then the second keynote speech will get started soon. So for the participants, ladies and gentlemen, would you please be ready again in front of your computer to participate in the second keynote speech. The second keynote speech is going to present Professor Buntara Eskan, okay? And the session is going to be chaired by Professor S.A. Kristiawan, PhD. Okay, so while Professor S.A. Kristiawan is getting prepared, now please allow me to present the MCs of the speaker and the moderator. So for the committee, would you please present their CVs on the screen? Professor Buntara Eskan is a professor of engineering college, Nihon University, Department of Architecture since 2015 until present. He is the university graduate of Tokyo Graduate School, the division of structured computational mechanics, doctor, completed in 1994. He accomplished the master degree in the University School of Engineering, Structural Mechanics, Computational Mechanics master course, completed in 1991. And then he pursued his bachelor degree in Bandung Institute of Technology, Civil Engineering, Structural Mechanics, Computational Mechanics in 1988. Sorry, because the writing is too small, so I have to get very close to the screen. Okay, now I would like to present the next curriculum vitae of the moderator, Prof. Kristiawan. Profesor Stefanus Adi Kristiawan, ST, MSc, PhD, is the head of doctoral study program of civil engineering of Universitas 11 Maret. He accomplished his bachelor degree in 1995 in civil engineering of Universitas 11 Maret, and then he accomplished his master and PhD degree in the University of Leeds. His master degree was achieved in 1998, and the doctoral degree was obtained in 2003. Okay, Prof. Kristiawan, now the floor is yours, and you are supposed to chair this second session. The stage is yours until 10:55. Thank you.
Thank you, Mr. Yusuf Kurniawan. Good morning, ladies and gentlemen. Good morning also to our second keynote speaker, Prof. Bundara. I hope everything is going well over the Japan, Tokyo, Nihon University. We are very honored to have you with us in this conference. Professor Buntara will give speak on the topic of design philosophy for building comfort level performance. It is very interesting topic, and this topic of research has been developed by Prof. Buntara at Nihon University, and particular interest, particular work that have been patented related to this topic is about shaking index value. Yeah. So before we get started, I would like to remind all participants to mute the speaker during the presentation. You will have the opportunity to raise your question at the end of the presentation, or you may prefer to submit type question by typing your question into the chat room. Yeah? And we hope that we can address all the question if the time allow. Yeah. So, Professor Bundara, you have 35 minutes for your presentation, and time is yours.
Okay, thank you very much. Is everybody can listen to my voice? It's okay. All right. Thank you. Good morning, respected rectors, deans, and all the participants. And thank you very much to Professor Kristiawan for introducing me, and also Mr. Yusuf Kurniawan for introducing my CV. And may I share my screen?
Please.
Okay.
Yeah.
Yes. Thank you. Okay. This is my screen. So can you see Professor Kristiawan?
Yes.
Okay. Okay. Let me start my talk. Today I'm going to talk about the design philosophy for buildings comfort levels performance. And my name is Buntara from Department of Architecture, College of Engineering, Nihon University, Japan. As introduced by Professor Kristiawan, that actually this research I've been developing in Japan with my collaborations in collaboration with Professor Han Aili. I hope she's listening to me now. I'm not sure. From Semarang, from Universitas Diponegoro, and one of our PhD candidate, Mr. Nanang Gunawan Waryanto, and he has been working hard to help us completing this research. And these are the related works as mentioned by Professor Christian once before, that we have published 2 papers indexed by Scopus, and we have also patented two patents so far, one in Japan and one in Indonesia. In Japan, we patented in 2019, and in Indonesia just last year, we have just patented another patent in Indonesia. And and my talk will be is about the quantitative evaluation of earthquakes, to be more specific and easy to understand, because the title is very, how to say, is very rough and difficult to understand. I try to use some conference themes by using the conference theme topics. That my talk will be the quantitative evaluations of earthquake-induced shaking. So if you feel earthquake shaking, then this is the things that we are doing for design, for testing, retrofitting, and monitoring of buildings. So these are the main topics of my talk. There will be no, because this is the only philosophy, there will be no difficult equations and so on. So I will keep aside all the technical terms. I just talk as a philosophy. Okay, let me start with these are the 10 countries with most earthquake occurrence in the world, and it has been recorded. As we see here, Indonesia actually is number 1, and Japan is number 2. You see, and then why Japan is earthquakes, the country of earthquakes is called, because from during the 1 century, from 1900 to 2017, these are the recorded big earthquakes. If you see here that the magnitude of the earthquake is above 6, so you can see here Indonesia is actually let me use this one, is something surrounding here, and Japan should be around here. So you can see these 2 countries are the most earthquake occurrence in the world. And then the other reasons is why there are big earthquakes there is because Indonesia and Japan are located near the junction of 4 big plates. You can see here, they are Eurasian plate, North American plate, and then we have here Filipino plate, and these are Pacific plate and Australian plates. These 2 countries have similarity because they are located just near the junction of 4 big plates, and these plates are moving anytime. So these plates are moving all the time. I mean, all over the year. So when there is troubles between the plates, then we can feel earthquakes there. And for the reference, in 2011, there was an earthquake in Tohoku, East Coast. We call it the Great Tohoku earthquake. And actually, the place that I'm living now in Fukushima is only 60 kilometers from the coast side. So I can feel about very strong earthquake at that time in March 2011. And then 7 years after that, we also found the big earthquake in Sulawesi Island. So these are just description why earthquakes are attacking these 2 countries. And let's see the seismic design, earthquake resistant buildings in Japan, especially in Japan. I want to bring up here the development of earthquake resistant building technology in Japan has been started since 1891. So it's a long time ago. It's more than 1 century behind. So they have been experienced, I mean, Japan has been experienced many building collapse due to major earthquakes. And this encouraged them, this encouraged all the researches and technology developments in Japan to to consider this disaster by earthquake. And then since 1919, so it's also about 1 century ago, the law has been enacted in Japan. That if you design an earthquake-resistant build, you have to, if you're designing a building, then you have to design based on the earthquake-resistant buildings, including bridges in Japan. So this is the things that why Japan is very developed. I mean, they are ready to to be facing many big earthquakes. This is the history of the design of earthquake-resistant building in Japan. Let's see the statistic. I took this one from the Japan Meteorology Agency. These are the statistic of from 1995 to 2018. So it's about how long? About 23 years time. And this is in a log scale. Then we can, I took from the JMA, this Japan Meteorology Agency, the statistic on human casualties, building collapse and damage. And then we can, if I plotted this and I exclude the the 2011 big earthquake because the damage is big. Most of them are due to tsunamis, not because of earthquake. So I took the data here. So you can see there is a data empty here. And also there are many data empty here. I keep it out because it's related to tsunami. So it's not related to the earthquake. So I just choose the one with related to the earthquake. And if we can see from this graph, you can see the red one is death or missing statistic. Compare with the injuries, red and green, I mean, injuries. You can see the death or missing are less lower than the injuries, the amount of injuries. So you can see injuries is overhead death or missing people. And from the structural point of view, we can see the building, which is failure or collapse, is also less than the damage, building damage by the earthquake. So it's very interesting because in the occurrences of earthquakes, and most of the damage are not because of, not causing the people to death. I mean, of course they are, but still less than the compared with the injuries people. And maybe some of the injuries people are becomes dead, maybe some of them, and we don't know because we don't have the detailed data of this. And then the structure, also the damage structure are less in amount compared with the structural damage. So on the right side, there is another graph I took from this data. And actually this data has been compiled by JMA, and they also put the data about the earthquake magnitude. So this earthquake magnitude is based on the Richter scale. So everybody has known a Richter scale here. So this is the same data. It's from March 1996. I'm sorry, it's not 1995, it's 1996 to June 2018. And if I plot these two data in the the same scale between the Richter earthquake magnitude with the seismic intensity level. The seismic intensity level is the things that I'm talking is the seismic intensity level of JMA is a Japanese one. Then I will talk about the other seismic intensity level after this. And then if you can see that there is the correlation between the seismic intensity level of JMA with the Richter scale magnitude are not correlated well. I mean, if this is the 45 degrees relationship, so there are many earthquakes that are actually giving very big Richter magnitudes, but it's very small intensity level. So what are the difference between two? The earthquake magnitude in the Richter scale is is the source, the peak of the earthquake, the magnitude of the earthquake from the source. So it's actually is very much interested by the geologists, geophysics, not for the for the residents or not for the ordinary people, I mean. And ordinary people in Japan is more interested in seismic intensity level. This is what they feel when the earthquakes come. So there are some numbers I will talk in more detail later after this. And this actually in Japan, if there is an earthquakes come, and it's going to be reported on the television broadcasting and broadcasted. I mean, like NHK, Nihon Television broadcasting system, and many other television, and all of them usually are broadcasted in the term of seismic intensity levels developed by JMA. So they don't report in terms of Richter scale. Of course, the Richter scale they talk in the very beginning. So because this is just only the magnitude of the earthquake, it doesn't mean that your location now will feel the same magnitude of the earthquake. So it's very interesting. We don't use Richter scale too much. I mean, just in the publication, for example, like the greatest earthquake in the Tohoku area, we just use, it has magnitude 9.0 at that time, but we don't use this too much. In the television, we just see, oh, in my location is about seven, okay. In Chiba Prefecture, for example, they feel 7. And in my location, we feel 6 at that time. So this seismic intensity level is much more different with Richter scale magnitude. That's what I want to say. And this seismic intensity levels in Japan now, they have 10 ranks of it. And this seismic intensity level has been developed since 1884. It's about more than 120 years ago. And at the time, the Japan has developed 4 ranks for this seismic intensity level. And it's developed by the Japan Meteorology Agency, because this agency is responsible for the early warning system, which has to be broadcasted to this all television station. And then the way they do this, they put a kind of device on the ground, and then this device will transmit the data to the television broadcasting system, and then they will transfer to ordinary people. So in according to the area where you are living. So it's very interesting. Then in Indonesia, well, I have to talk about Indonesia, because most of you are from Indonesia. And yes, I mean, we have now the BMKG have been working together with ICL, is Institute of Care Life from China, in 2019, it's about 2 years ago. I think they have developed the early warning system. They are using satellites, which is installed by the China company. And one of thing that the magnitude of, is based on the magnitude of the earthquake. So they don't broadcast the magnitude of the shaking that human being feel. So it's a little bit different. So they are reporting the earthquake epicenter magnitude. So it's the magnitude of the earthquake, the source of the earthquake. So it doesn't report it the magnitude of in every locations. Of course, they are putting many stations in every places, and they counted these stations are mainly used for counting the magnitude of the earthquakes where it is happened. So, for example, if we heard that magnitude 7 is occur here in the southern part of Java Island, something like that. So I think they are broadcasting in this way. So it's different between Japan and Indonesia. And then here is the purpose of study. And from the things that I felt that when there is a building shaking during the earthquake, then we need to investigate shaking intensity quantitatively. This is the things that we are trying to do research in this field, because we feel that it has to be shown quantitatively, not qualitatively. And I will talk later about what is the difference between quantitative and qualitative. And has to be technically sound to be accepted as research, and has to be expressed in numbers. And to do that, we need structural analysis should be considered in our study. And then we have to also to find the potentials of practical applications. If you don't have a potential application, then your study might be useless or nobody will have interest to your research works. So this is the purpose of the study, that by examining all the earthquakes seismic intensity level. So we start from that point that we want to use the shaking intensity level to evaluate the structure shaking quantitatively. So this is the main purpose. And these are the earthquake early warning system in many countries. So I cannot show you all the early warning system in countries. And Japan has, and most of them are described in a term of characters and wordings, and like the modified Mercalli intensity. This has been adopted in Indonesia, I know. And Japan, as I said, it has 10 ranks. So from 0 to 7, we have 6 weak and 6 strong, 5 weak and 5 strong. Then it becomes 10. The things is this is the modified Mercalli intensity level, which is expressed only in the sentences. So I found this from USGS. So if you're interested, you can try to find it. And this is, I found that from Thailand. Thailand also has developed this kind of early warning, earthquake early warning systems. And the thing is, this has been distributed to the ordinary people, but very rare we use this. I mean, in Japan is very often we use, because we refer these numbers as they broadcasting to the television stations. Then we can see these numbers on the television, and then we know how we feel the earthquake. And then the others, I think, very few used in the in the how generally, very few to use generally. Okay, and then from this from these observations, and we decided that we adopt the seismic intensity level by GMA1. So these are the GMA1. This is also the GMA1. Then very rare people seeing this. But if you search from the JMA, the Japan Meteorological Agency's website, that we can see these two like earthquake early warning system. And if we translate to the English one, we have these sentences. And these are qualitative. Originally, this seismic intensity level are qualitative. You just can see that, oh, how you feel when the earthquake comes. Like you cannot stand when the earthquake of the 5 weeks coming, then you have to how to say, to be stand and by touching the wall, otherwise you cannot stand. Or it's become, when it comes to 5 strong, then oh, you cannot stand anymore, so you have to stay under the table, for example. I don't know which is it the correct one or not. And then these are the qualitative, and we want to change this to a quantitative one. And the problem is with this equation, that is not the problem. This equation is already provided, but they don't use it for the evaluation of shaking. They use it just for reported the earthquake early warning system. That's what I mean. And then the things that we do is the evaluation of shaking in Japan, they use the response accelerations and dominant periods of the point or the location or the somewhere in the building where you stand. So you have to calculate the accelerated response there, and then you have to know the dominant period at that location. Then you can find, you can compute the seismic intensity level. The equations are there, but nobody use. And then the others is are qualitative. These are the difference that we are doing, and we put this structural analysis later on. I will talk about that. So that we combine this, and the quantitative evaluation of we based on a scientific approach. This is what we are claiming. I don't know if everybody disagree or not. And the shaking intensity level at this floor in earthquake resistant building. Of course, the building has to be designed resistant to the earthquake in the very beginning. We are not talking a building is not earthquake resistant proof buildings. So we have to be presumed that the building has to be resistant against the earthquakes. And then they evaluated based on the time history dynamic structure analysis. So this is the new things that we put our proposal into a package that actually we can calculate that, and then we can have many applications from there. And then if suppose there is a building during the earthquakes is shaking. Shaking is when your building is moving from the left to the right side directions. And suppose we have three-story buildings here. The second, maybe three-story, the second floor, third floor, and the roof. Then we can plot here when the building, when a certain type of earthquake comes, how it reacts, how it gives you the shaking level. So it's different because the things that the seismic intensity level that is reported by the JMA is only on the ground. So this has nothing to do. If you're staying in apartment building, you're staying in a very high floor, then you will feel much more higher seismic intensity level than the ground. I think I'm correct with that. And then, and this is the things that we are emphasizing our study here. That we have to compute in every floor, and then from there we can see what happened. For example, on the second floor we have the seismic intensity level of the magnitude 4. And then this is examples. On the third floor, five weak, and then the fourth floor is 6 strong, something like that. So you can compute this quantitatively based on the dominant period of the location where you stand on, and then the acceleration. So I don't want to talk detail. This is not the maximum acceleration. This is the 0.3 second where the minimum of the maximum velocity. This has been defined in a very complicated equation. And then I'll skip that part. And then actually we do quantitative evaluation here so that people can use these both between figures and illustration both at the same time. Okay, let's talk about another thing that our PhD candidate is Mr. Nanang's works. We have developing a map checking intensity level in Indonesia, and he has been working very hard. He took all those 1,788 sampling stations from all over Indonesia, and then we can develop a response spectra from this sampling location. So and then from this response spectra, reversely, we can make an artificial earthquake wave. From this artificial earthquake wave, it depends on the ground. Every ground has a dominant period. So it's depend on the ground. Then we plot on those seismic intensity level, which is used in Japan, and then we can draw the map of seismic intensity level in Indonesia in very soft soil. Actually, shaking will be magnified by at the soft soil. So we can draw a map. So if you want to draw a map on the hot soil, it's okay, but maybe the number will be reduced, something like that. So this is a sample what we have been doing now. Now I will have to wrap up my talk about what is the merit of quantitative shaking evaluation. One is to gain a comfort living. This is a luxury matter. As you know here, I'm not salesman of the automobile. What Toyota doesn't tell anyone is that they are selling Harrier and Lexus, right? But the Lexus has maybe more than 2 times the price of the Harrier. What Toyota doesn't tell anyone is the engine are the same. The engines of both automobile are the same. Then what is the difference? The difference is the comfortness of the Lexus are more expensive than the ordinary vehicle. So they are selling luxury here. This is the same like what I'm talking not today. And if we have buildings resistant, of course, earthquake resistant, the building is strong. Nobody will suspect that the building will collapse in Japan. Everybody's believe that the earthquake resistant design in building in Japan is very, very safe. Then it's up to you. If you want to live in this situation, it's okay. So if it's a luxury matter, if you use the best isolation here, then you can feel that there is no shaking at all. So this is just a luxury matter, one of the application. Maybe it's not applicable yet to Indonesia. I mean, there are still many buildings not earthquake resistant yet. And then the other application, what we are thinking is to design a building performance during earthquake. So when the building is not exist yet, then we in the design phase, that we can simulate, if we can evaluate quantitatively. For example, what are the earthquakes? El Centro, okay, when El Centro comes, or earthquakes similar with El Centro comes, so this building will be shaking. So how big is shakes? Then we can compute that. Then we can design according to the needs of the residents of the buildings. So it's a design tools. And the other applications is what are very interesting is in Japan National Research Institute of Science and Disaster Resilience, we have been conducting 10 floor. This is a real 10 floor story. It's about 27.5 meters with the weight about 1,000 ton force. So they don't inspect the way I'm talking today. But if we use this like how to say it, like a device to find out how much the shaking intensity level here, then we can do more like Professor yeah, the professor from Taiwan said that okay, let's do bracing here. Then we can do any kind of and strengthening methods here. Then we can observe whether this seismic intensity level can be dropped down or is not. So we can use this as a tool to test and inspect the building performance during earthquake. And also, actually, this is in our campus during the 2011 earthquake. Now we are doing the bracing also, but I think this is the passive one. We just put the bracing here. And at the time of the earthquake, oh, it's really terrible. And you see, our building has no one of our building has been collapsed, but insides are very, very damaged, many damaged. Oh, it's very terrible. The buildings are damaged also, but not collapsed. And when I realized that they are also using the seismic intensity level to define this building is in which ranks after the earthquake. So it's if it's they use the seismicity index. So it's similar with the seismic intensity level in Japan, but they use it only qualitatively, only 4 ranks. So only 4 ranks is really doesn't tell you much about the damage of the building. And okay, this is the final. I want to wrap up my talk today. The other application, what are the potential that we can, if we can compute the seismic intensity level quantitatively, we can measure the performance of a device or instrument like a brace, shear wall, or base isolator. Then it's very, very important tool to do this. Otherwise, you just, okay, after I build this building, use base isolator, and then it doesn't shake. Then it's only qualitative if you use install brace. And how good is the strengthening method of you? Then you have to show them with numbers. So if you have the measurement in a quantitative way, then you can talk much here. And then you will sell more buildings here to the consultant or contractor. And the other thing is we can mitigate the seismic hazard by establishing a detailed earthquake early warning system. Detail, I mean in every floor. For example, you're living in a high-rise building, so every floor has different seismic intensity level. So you can develop a mitigation seismic hazard here. in a building, a smart building, or you can even you make a smart building or something. And then the things that we are doing now, we are developing a device, real time monitoring, that we use Raspberry. I think everybody knows it's a very small size computer. And if we combine this with the accelerometer module and LCD display, then we can compute the seismic intensity to a specific location or floor of the building. Okay, I think I just talked too much without any technical equations, difficult. And thank you very much for your attention. I have to close this just 30 minutes, I think. Professor Kristiawan, am I? Okay, if any question, and if there are any question, I will be happy to answer.
Okay, thank you, Prof. Bundara, for your very nice presentation. Yeah,
really,
talking about philosophy. Yeah, and so that we can understand what your research is about and what your propose seeking seeking evaluation quantitatively. Uh, so I open the uh, and Q&A session. So if anyone would like to raise a question, please, you can write your question in the chat room. And we have one question from Mr. Erwin Lim. Do you need instrumentation on each floor of every building for the quantification?
the answer is yes.
Okay.
Mm-hmm.
So straightforward answer. Every floor there is a instrumentation. Okay.
Okay.
Anyone else, or maybe Prof. Buntara want to elaborate your answer?
Which one? Oh, okay, okay. And there is a question here for mitigation and monitoring purpose, how to determine the warning level or threshold. Okay, the answer is okay. Let me show you one of our slide. The threshold has to be determined by us. At the time being, there is no threshold. So this is the answer. You see, if the threshold you define, okay, let me erase all my comment here. Wait, just a minute here. Maybe erase all thing. Okay, there is one good questions asking about the threshold. Is already we already discussed about the threshold, and we put on the maybe number 4 is the good threshold, because you don't want glass or dishes are falling from the shelf, and this 5 week is quite strong shaking. So maybe it's around 5 is the best way, I think, the threshold. Someone asking the threshold that we have to propose this, because this is just our decisions. Am I did I answer your questions? Okay, Mr. Muhammad Ibnu Syamsi. It's okay. No, okay, no answer. Okay, now the other question is from Didi Agusta Wijaya. Okay, what are the difference between JMA and MMI? I think I talk maybe it's a little bit fast at that time. JMA is using using their seismic intensity level as a earthquake early warning, but the MMI is using magnitude of the earthquake. It's the source of the magnitude. So more technically, let me talk more technically. If you are using the source of the earthquake, it doesn't tell that the location where you are staying now has the same shaking intensity level compared with in Semarang or Surakarta now. So it's depend on the soil conditions, right? So if you have, then if the Japanese one is the seismic intensity level at your locations, but still is on the surface, on the surface. What we are developing is not only on the surface, but inside the buildings, everywhere where you are now in the building, on 10th floor, 15th floor. So you have different shaking intensity level. So this is the answer to Mr. Didi Agusta Wijaya. Am I, are you satisfied with the answer?
Okay, thank you, Prof.
Okay, another questions? I
Yes.
think MMI using Richter magnitude scale.
Yes, right.
Am I correct? Yeah, okay.
Thank you.
Oh, you're welcome. And then Mr. Aditya Wiltomo, what was the first thing when the earthquake occurred in Japan? What was the first thing? Oh, okay. The answer is you just stay. Don't go out of your building because the building in Japan is already earthquake resistance. If you go out, then you maybe get wounded by falling things outside of your building. So this is in Japan. It's different. And what is the role of the government in handling the first time? Yes, they are reported through radio, television, and it's very, very fast. Okay, am I correct? Am I answer your question, Mr. Aditya Utomo?
Yes, thank you, Mr.
Another
Tunggal.
questions? No.
Enough.
Okay, and then from Mr. Abdul Rahman, how would you anticipate the risk of the damage on the sensor due to earthquake? That may be because erroneous reading. Okay, the answer is now we are doing the research there. And the sensor, whether it's many noise there, then maybe we have to eliminate the noise, and then we have to eliminate all the risks of being how to say mistaken, error like error reading. Yes, we are doing a research now, Mr. Abdul Rahman. Very good questions. And then another question is Mr. Remy Joseph. Majority doesn't earthquake. Yes, as I told you, Indonesia is a little bit behind in this field, and the responsibility of the building in Indonesia. Yes, but only for the earthquake resistant has been designed buildings. Like in Jakarta, we have, I think, many earthquake resistant has been designed in Jakarta. Then they can adopt my concept. And then now Miss Surya Dewi Puspitasari, philosophy, what Japan could be. Yes, as I said that it cannot be adopted 100% because still there are many buildings are not earthquake resistant. Okay, I felt that is in my apartment, 11th floor during earthquake occurred in Sapporo. So you're in Japan, but totally insecure when the lower magnitude lowers. Yes, and again, if your building has different dominant time period, then it will respond to another earthquake. Then we have to evaluate this all structural by using structural analysis and ground. We use a soil analysis, and it has to be analyzed quantitatively. Then we can know that your building maybe is response to the very low frequency of earthquake. Maybe there's the answer. And then, Professor Agus Marioto, Unsud from Unsud. Yeah, I know you. What is the advantage of building in Indonesia when Mr. Nanang inventions when apply in Indonesia? Yes, I think I have said a couple of times that we have to do earthquake resistant building first. And then now regarding the code, now we have some, maybe it's difficult to put it inside the code because it's a kind of luxury. You need more money. The economic impact will be very, very big. So it's become still a luxury matter in Indonesia, I think. Like you're buying Harrier or Lexus, something like that. So this is the answer. It's up to you. Even if it's checking, but it's still safe. So that's the answer. Okay, and then is needed. Okay, no other question, I think, Professor.
I think still one question.
Yes.
Does comfortability is need when earthquake happening in Indonesia?
Does compatibility is needed when earthquake happen in Indonesia?
Yeah.
I think so. At least like seismic intensity level in Japan, if we adopt in Indonesia, is better than just knowing the Richter magnitude, right?
Yeah.
Because if you only know about the Richter magnitude, it's nothing to do. Like you are staying in different location, you feel difference. Okay. So the shaking are different. So the things is with the Japanese seismic intensity level is because they are abroad broadcasting like there is an earthquake here. So they are broadcasting to all area. So in your area, you see that there are some coloring here. The yellow one is very low seismic intensity level in Japan standard. And there is a white one is your area is nothing, is okay. So they are just the first time, of course, they are talking about the magnitude of the earthquake is 9. Oh, it's big. Okay, now I see. Now you're staying in Kyushu Island. Oh, nothing to do. It's no effect. So I think this seismic intensity level is more important for me, for ordinary people to understand where they are staying and then how they are being shaken by earthquake. I think this is the answer. And then another one.
Yes.
This one.
It's true that the input on the sensor monitor about story displacement or perhaps anything else?
Thank you for the. Is it true that the input for the sensor monitor about story displacement? Yes, we have to. I think I show you on my last slide. Maybe 22. Okay, we have to provide this device with accelerometer module. Then we have to delete, eliminate all the noise, or maybe have to use another filtering here. Now we are conducting research in this area, and you have to be see, and then actually this is a computer, so you can save your data in a text file, and then you can analyze, you can do programming here. We use Python as a programming language here, and then to compute the seismic intensity level everywhere. So there is the things that we need. The other things we need the dominant frequency, dominant period of the building. The dominant period of the building doesn't change much in its building surface life, but we can put in the very beginning. You don't have to analyze the dominant frequency or dominant period of the building. Is it answering your question, Mr. Igre Eka? No, very long. Agatha Putra. Okay, another question. Okay, with the earthquake resistant building structure model explained by proof, is the column model installed diagram able to withstand earthquake force above 9? The answer, I don't know. You have to test because this we just developing a sensor whether the column is able to withstand. So this is, you have to ask Professor Huang how strong the bracing. Well, actually nowadays people doing numerical analysis to check something like that. But if the earthquake with force above 9 on the Richter scale is just under the building, I think it will not withstand. Magnitude 9 is a very, very huge. And again, it's depends how deep. Yeah, it's depend how deep the source of the earthquake is. As deep as the earthquake, you can feel a very small shaking. You're welcome. And then, okay.
Okay, thank you, Prof. Guntara, for addressing each question. Many questions has been raised, and it is indicating that many participants interested in your topic.
Thank you. Professor Solihin is here.
Okay. Now we are at the end of this second plenary session, and we should appreciate Prof. Guntara for delivering a very good speech, and let's give him applause.
Thank you so much. Okay.
Okay.
Useful.
We end this plenary session, and I would like to give this time to Mr. Yusuf Kurniawan. Please take over this session.
Yeah, okay.
Okay, thank you, Prof. Kristiawan. And once again, we would like to give appreciation to Prof. Guntara as done with his keynote speech.
All right.
All right, ladies and gentlemen, now it's time for us to move on to the next keynote speech. The next keynote speech is going to be chaired by Dr. Suryawan Murtiadi, who is going to present the last keynote speech delivered by Professor Edgar Bona. Before the next keynote speech begins, please allow me to present the curriculum vitae of the moderator. Insinyur Suryawan Murtiadi, Master of Engineering, PhD, is a senior lecturer of Department of Civil Engineering, Faculty of Engineering, University of Mataram, Indonesia. He pursued undergraduate in civil engineering, accomplished in 1989 from the Institute of Technology Surabaya, Indonesia. He accomplished his Master in Civil Engineering in 1999 from Faculty of Engineering and Applied Science, Memorial University of Newfoundland, Canada, with his thesis entitled Behavior of High-Strength Concrete Plates under Impact Loading. And his PhD degree was achieved in Civil Engineering in 2007 from the School of Engineering and Applied Science, Aston University, Birmingham, the United Kingdom. His dissertation titled Behavior of Concrete Frame Structures under Localized Fire Scenarios. He has some research interests, and they covers concrete material, concrete structural engineering, and building constructions or material. And please allow me to present the curriculum vitae of Professor Dr. Edgar Bona. He is the principal scientist and leader of the research team for structural material at VTT Technical Research Center of Finland. He is also the project manager in engineering consultancies in Germany. He spent 8 years as a research and teaching assistant for building materials and as a team leader for material mechanics at the Institute of Concrete Structures and Building Materials of the Karlsruhe Institute of Technology in Germany. He pursued his master degree, and he has 2 master degrees in civil engineering, first from the University of Karlsruhe in Germany and the Royal Institute of Technology in Stockholm, Sweden. And he achieved his doctoral degree from Karlsruhe Institute of Technology in Germany. His expertise is in durability of concrete structures, deterioration mechanisms, corrosion processes, and life cycle assessment. Now let me invite and allow Dr. Suryawan Murtiadi to chair this session until 11:45. Now the floor is yours.
Thank you very much for the Bapak Yusuf Kurniawan ya. Okay, good morning everyone. Uh, before we start, I would like to have little chat with Professor Wagner. Yeah. Where is your position now? In Finland or? Hello, Professor Wagner. Can you hear my voice?
Yes, hello. I can hear you very well. Thank you for the kind introduction.
Okay. You are in Finland, yeah? So early morning at the moment, yeah.
Yes, but it's all fine. The sun is already shining.
Okay. Okay. So we are very pleased and very proud to have you here. So we would like to hear your presentation today. And you have about you send your video, eh? So you have
Yes.
about 13 minutes, half an hour for presentation, and then we come to discussion for about 15 minutes. Okay. Okay, so
yes.
now I give time to you or the organizer because Prof. Corner already sent the video.
Yes. Thank you for the kind introduction. I'm here,
Yeah.
but we can listen to the recording now.
Okay. Okay.
And then
Yeah.
I'm happy to answer any questions.
Yeah. Okay. The time is yours now.
Thank you. A big hello from Helsinki in Finland to Surakarta in Indonesia. I'm very pleased that I got invited again to give this presentation, and I remember very well the very first ICRMCE in 2009, where I attended at that time in person to the conference. And I really hope that the COVID-19 crisis will soon be over, so that latest in 3 years I can be again with you in Surakarta. I would like to talk today about concrete innovations and how they are driving change in aging management. But before I start, a big thank you as well to my colleague Miguel Ferreira, who has greatly contributed to this presentation and the background research we are talking about today. So shortly, the outline. In the beginning, I would like to talk about what is the impact of concrete and what is driving concrete innovation. We look into novel material solution, into some special concretes, and how digitalization changes concrete technology and construction. Then a very important aspect about reuse of building components and the improved understanding of concrete aging. A very big part of this presentation is dedicated to service life design and how we can extend the lifetime of our existing structures and how we can predict their deterioration. But let's start. What is the impact of concrete? As you all know, concrete is the most used man-made material in the world. And why is it like this? It has simply very beneficial properties. Its mechanical properties are outstanding. Its versatility, you can basically do with it whatever form and design you want. It's very easy to produce, it's worldwide available, it's rather affordable and a good, resilient and robust material. However, there's as well a downside to this. Concrete sustainability is not good, and for every ton we produce cement, we almost release 1 ton of CO2 in our atmosphere. As well, the circularity of our material is not good. We recycle but we mostly downcycle the material, use it as cheap fillers under foundations or roads. We need to change this especially since our raw materials availability is questionable in future. But concrete is as well a very durable material, and we have a large existing building stock, and we need to look that we use it even longer. So a closer look into what is actually what are the drivers behind concrete innovation. First of all, we have already good safety and quality, but there is still a lot of measures we can improve these. And that is mostly built on digitalization, from raw material production to manufacturing, quality control during construction, and then following after a concrete condition assessment based on structural health monitoring or non-destructive evaluation. We want to increase the sustainability, as said, of our products and structures. That means we need to lower the carbon footprint. We need to decarbonize the whole way we construct. But we should as well extend the service life of our existing structures, increase their durability, robustness, and resilience. And then we know that our resources are scarce. We need to promote circularity, better recycling, upcycling for more mature and better use of our materials after we actually end the service life of our structures. Reuse these materials, design for reuse, more use of industrial waste, and so on. And of course, politicians and the society have already recognized this. There is a lot of new regulations underway which promote a better sustainability, a higher circulation of our materials. So this will have a strong impact on our way to handle our materials and to do concrete construction. But not only society and the politicians, as well companies have realized that their clients demand such kind of features, that their products are as well sustainable. So there are zero waste concepts and the use of other mineral side streams or mineral wastes for their products. But let's look into some examples of new material formulations, for instance. There is ideas for new binders, new binder chemistries. So we need to use to a higher extent SCMs and other fillers. Then we need to test how far can we drive that to replace and substitute cement. Or we look into totally new cement formulations or binder formulations. LC3, for instance, has excellent properties, excellent durability with regards to chloride ingress or ASR, has very low creep and shrinkage. And but then there is totally new binders as well. Non-Portland clinkers, for instance, bellite, elamite, and ferrite. Or we use alkali activated materials to a higher extent. There is even potentially zero cement composites. However, we require their new material, waste materials, or for instance blast furnace slag or fly ashes, and they will be as well not that much available in future due to the decarbonation of steel industry and coal burning power plants will certainly as well be reduced. But not only binders, we need to look as well into aggregates. We need to recycle aggregates from demolished concrete. That means we should look into smart crushing to separate better cement content from sand, from coarse aggregates. Or we use other waste materials to replace our aggregates in the concrete, like slag granules, plastics, remains from forest and agro-industry. Or we manufacture artificial aggregates, for instance from clay, a material that is available globally in large amounts, or other mineral deposits like mine tailings. And then we need to make as well our materials more circular. That means we need to reuse our aggregates well, reuse even our binders. Once we made and achieved in separating in the demolishing process the binders better from the inert particles, we can as well build higher quality new materials. We don't need anymore to downcycle concrete to push it, demolish concrete under a road or under a foundation. But we need to change the whole design so that we can reuse whole building components. Design for disassembly, the integration of design information and service life engineering through the to digital technologies over the whole lifetime of the structures. And special concretes have been very interesting. There were great and are great developments on the way. And for instance, already in 2009, Eric Schlangen has given at this conference a really interesting presentation about self-healing concrete. And in the meanwhile, we have done a lot of research work with him as well, and have developed self-healing concepts and improved the tightness, for instance, from water reservoirs or pools and so on. Then there is self-sensing concrete. So that is concrete with fillers from carbon fibers, steel fibers, carbon nanotubes and others that have the ability to make sensing of internal conditions like stress and strain or temperature possible without applying extra electrical sensors. Then engineered living materials is a totally new field, and so microbes can actually help to build our structural materials, solid materials, insulating materials, hopefully building materials with proper strength properties as well in future. But most of all, we need to develop materials that can capture CO2. So based on CO2 mineralization, we convert gaseous CO2 into solid mineral carbonates like calcium carbonate within the concrete, and by this reducing the CO2 footprint. I want to give you one example. VTT, we have developed with our team a so-called CO2 neutral or even negative concrete. We call it CO2crete. And we use gaseous CO2 during the curing process to incorporate it into the concrete while hardening. And doing that, we can actually take up to 80 kilograms of CO2 per cubic meter of concrete. By this, we can save enormous amount of CO2 emissions and lower the carbon footprint of concrete tremendously. This is quite a promising look into concrete products in future. Then concrete technology in general, the whole life cycle of concrete can be improved using digitalization and all the options digitalization offers. So if we measure and sense concrete parameters, concrete properties from its early production phase, manufacturing, via the transport, the whole construction chain, and over the remaining lifetime until demolition of the structure, we can use this in a very smart way based on sensors we have, based on other means of digital measurements. And then we could, for instance, feed this information as built information into build information modeling, so-called BIM systems. And as you all know, during the lifetime of the structure and even during the construction process, such data goes through many hands, and there's a danger that data and quality data in particular is manipulated. We could take modern blockchain technology to secure this data and to travel with the data and the material through the whole circle. So for instance, as an example, all the fresh concrete properties that are measured in the mixing plant can be handed over automatically to the truck that drives the concrete to the building site. And when the pump can make a decision to accept the concrete or decline the concrete based on the quality of the concrete in the truck, this could be totally automated without any human interaction based on digital quality measurements and on blockchain technology and building information technologies which travels that information with the material. Okay, then concrete construction, what does that have to offer? There's plenty of new ways to construct. Just two examples here. There is SC modular construction, so steel, concrete, steel components. You have a picture on the upper right hand side from our laboratory. So the steel plates with studs replace the formwork of the concrete, and you only fill in inside concrete. There's established design rules for that already. It's a very convenient and very economic way of building, for instance, heavy structures in power plants or foundations or walls in flowing water, seawater, or others. And then 3D printing, of course, everyone has heard about this, hopefully already, and we can print entire structures and houses nowadays. There is great potential for savings of waste, of reducing labor costs and production time significantly. Then a very important topic is the reuse of building components. As said, we want to prevent waste, we want to lower the carbon footprint, and one way is to design a building already in the design phase with having the end of its lifetime in mind and the way we deconstruct and may reuse it again. So we need to learn how to design for deconstruction, how we design for disassembly and reuse of the components. For that, we need as well to trace how these components and the materials are aging during the lifetime and keep it with that information with the materials. And we have done that in projects with for steel construction. It's established there already to a certain degree. We need to. There's great examples like the Olympic Stadium in London with this kind of design approach, but now we need to do it as well for concrete and concrete structures. And as last but not least, we need to improve the understanding how our structures are aging. So a strong research focus still on concrete aging. It's an old topic, but there's still plenty of open questions, and what we are lacking mostly is reliable models describing the concrete aging. So, for instance, complex deterioration mechanisms like frost or corrosion or internal swelling reactions, ASR for instance, and how do all these new material types I have shown will behave in future? How do we get the models for these? How can we be sure that they're durable? And one way is, of course, to have better integrated structural health monitoring systems, wireless technologies, integrated data collection, and further on with that data having decision-making tools, machine learning, AI based analysis, and better tools for non-destructive techniques to make proper condition assessments of our structures. And all that information can actually go into aging management systems, holistic aging management systems, where we proactively follow the condition of our structures and make predictions on how they will behave in future. But now to the last topic of this presentation. It is about service life design and how we can improve that, and how we can use it to extend the service life of our existing building stock. If we look into the phenomena of reinforcement corrosion in our reinforced concrete structures, you might be all aware of this diagram on the right hand side. So if we look into the damage over time, we can distinguish between two periods, the so-called initiation periods. During that, the conditions for reinforcement corrosions are set. Concrete carbonates, for instance, or we have chloride ingress, and both leading to a depassivation of the reinforcement, which then, when happened at the end of this period, only is allowing the start of the active corrosion period. And that takes place in the so-called propagation period. There, totally different conditions are important, like the temperature, moisture, and oxygen availability. And it is so that the common approach in service life design considers only the very first initiation period and the end of this period, here denoted as T1, as the limit state. So we do not accept cracking of concrete and active corrosion in our design. But we all know it can corrode quite a while until the first crack happens, and even further until spalling happens. And shouldn't we use that extra time we have? Isn't that promoting better sustainability of our structures if we are better able to predict when real damage happens and not only depassivation of the reinforcement? So let's see how we could do that. There is already, we're not the first ones to do that. There has been old approaches, and one is in Life 365. Here you look on the left hand side into the probability of limit state failure on the y-axis over time. We have the initiation period, and the longer that time goes, the higher is the probability that we reach the end of service life defined by the depassivation of the reinforcement. But as we know, we can still afford certain time of propagation of active corrosion. In that approach from Life 365, it's just added a couple of years, X number of years to that lifetime, and that defines the new limit state. Here shown at this time. And then there is another approach of the FIB described in Bulletin 34, where it's understood that even propagation is as well a process that starts and develops over time and gets bigger. Corrosion is increasing over time. So at the end of initiation, we start a new period of propagation, and we need a new model for it. But now it's the problem that we, for instance, give a certain threshold of acceptable limit state for initiation. It has established a reliability factor of 1.3, which corresponds to a probability of failure of 10%. This probability of failure means that 10% of the reinforcement is depassivated. But does that 10% apply as well for active corrosion of 10% of cracking on the concrete surface, do we accept that? Then like the blue line and the red line would be the same. But if we don't accept it, we want to have it a bit lower because it's a more severe damage. We need two lines and two thresholds for this. That makes service life design very complicated. And we want to simplify that. We want to have only one line, and I'll show you how. So we can describe the development in the initiation period and the probability of a limit state failure with these two curves. Both are curves that are having scattering parameters. The upper one is the resistance of the material against depassivation. So it's concrete cover, chloride ingress, like diffusion parameters of chlorides. And then we have the active corrosion, the active concentration of the chlorides going in or carbonation of the concrete determined by the line S. And where both scattering or distributed curves are meeting, we have a failure. We now look into the propagation period. We can do the same. The reinforcement, the resistance against reinforcement corrosion is the resistance against crack development. And that is a time-dependent behavior, as is the active corrosion of the reinforcement, which actually starts at the time of depassivation. And they overlap as well, and all these functions can be described as probability density functions with the formulas given on the right-hand side. And now we need to make from these two probability density functions one. And that we can do by coupling these limit states. So first we say we start at the time 0 and the crack appears at a time t when we have a crack with a width of, for instance, 0.05 millimeters on the concrete surface. The corrosion is initiated at the time tau, which describes the active corrosion duration, tau, t minus tau. And then we can derive the combined probability distribution of the time of cracking with the first formula given here. The start of the corrosion propagation depends, however, on the corrosion initiation, but otherwise it's being totally independent of it. That means we can actually replace the conditional probability density function with the corresponding marginal probability distribution. And then there's only positive times possible. So the probability distribution can be simplified to the last formula. And that one requires only one limit state requirement, only one limit state. That makes design a lot easier. Okay, now an example how to do that. Initiation phase we can describe with the model described in the FIB bulletin already in 2006. Propagation period, we can use a model I have derived in my PhD work in 2013. We look into a case example. We have a reinforced concrete wall located in the tidal splash zone. We want to build it from a SEM 3A and with a water binder ratio of 0.55. And we want to see it should at least become 50 years, so a 50-year service life is our target. And then we look into two different scenarios. One is fast corrosion with 35 microns per year of rebar loss, and one is slow corrosion with only 10% of that rebar loss, 3.5 microns per year. For modeling, we need to have all these parameters. Please look into that in the paper, which is in the conference proceedings. So the example calculation, and here the results. We look again into the probability of limit state failure over the time. Lifetime 50 years. If we use current design procedures, then we actually end up here at 21.4 years, we will have a probability of 10% that the reinforcement is depassivated. So that means we don't reach the 50 years. And if we add the time of corrosion that we say we allow another 10% of surface to crack, then we actually will reach 42.9 years of service life. Still not the 50, but we have already increased the service life in our design of 100% simply by considering propagation phase still as a part of our service life. Now, how does it look like for fast corrosion? Again, the same. After 21.4 years, we end the service life if we only look into initiation phase. And since corrosion goes very fast, we will add only very little to it so that we increase service life to 11%. But we said we use now the same probability of failure of 10%. It might be a bit high if we look into the limit state for cracking of the concrete surface. 10% of cracked concrete surface is quite a bit. Many owners might not happy with that appearance and might want that to be lowered. What if we look into 5%? It's the orange line here. Then we actually see that we already reach our end of service life, including propagation phase, after 20 years. That is even shorter than our current design procedure of 21.4 years. So we have effectively a loss of service life of about 6%. And we only combine statistically the way we look into these design criteria. So we have not changed anything in the structure, use other material or use another model. So now we need to question, is the service line based on initiation phase? Might it be even not on the safe side for certain conditions in our design? Of course, this is a quite provocative question. I'm sure we are still, it's a safe way to design like this. It's probably too safe not to consider propagation period, but it should highlight, and we should understand that the discussion on selecting proper limit states is crucial for our service life designs, and we need to have a lot of discussion still about this in future, I hope. With that, I'm at my last slide, shortly final remarks. So we have understood there is actually no clear alternative to structural concrete right now, but there's plenty of innovation on the way. We will find new binder types, new aggregates, new formulations on how we make our concrete of the future. We will certainly need to increase circularity of our materials, better recycling and reuse. We will introduce a lot of digital technologies, improving the quality of how we build and creating the basis for our reuse of elements and structures. Then we will probably as well change the way we construct in future. 3D printing is one way, and we want to reuse as much as possible our existing building components and materials. So we get the highest benefits through extending of our service life for the building stock, because new construction means, of course, as well, we will create new emissions and will use new material, virgin material. So we should extend the lifetime of our existing structures as much as possible. And service life design can help to utilize the full potential of our building stock. With this, I'm at the end of my presentation. I thank you very much. I'm eager to hear your questions, and I wish you as well a great and nice conference in the next today and tomorrow. Thank you very much.
Okay, thank you very much, Prof. Warner. It's a very interesting topic and the great presentation and descriptions of concrete innovation, driving, aging, management. And I believe Prof. Warner is the man in this area. Any question in the chat room? Okay. We have couple of questions now. Okay. Okay, Prof. This
yes
from I don't know.
I see the first question in the
Oh,
chat.
you see the
Yes.
question. Sorry.
Regarding
Okay.
how to determine the service life of the concrete structure.
Okay.
The answer is not very easy or not very straightforward, because it depends on what endangers the service life. So it's mainly dependent on the deterioration mechanism. So I have given in the presentation when there is corrosion of the reinforcement the main problem of the structure. But in our concrete structures, we have plenty of other problems. That could be, for instance, as you heard, I'm coming from Finland. It's a very cold country, so frost is a problem for us. If the water in the concrete freezes, the concrete cracks and it's falling off. And this depends very much on how often we go from freezing to thawing, and this deteriorates the concrete as well over time. So this can happen then very quickly, within very few years, faster than corrosion. But we have good ways to prevent that. And other example is alkali silica reaction, as well a reaction where the alkaline cement creates an environment in which the aggregates used to produce the concrete are showing a swelling reaction and produce a gel, and this gel is then leading to cracks in concrete. So we need models, and this is the main point. We need models that describe this deterioration process in detail with all the influences, like the weather from outside. If we have moisture, what is the temperature? How much do we have of these deteriorating elements like chlorides that come from seawater into concrete, and so on. And with these models, we have a chance to make a prediction. And that prediction we should use as the basis for our service life design when we plan new structures, already to see how resistant we need to design them. I hope this answers your question.
Okay.
I see we have some more.
Yeah. Some more question. Yeah. Okay. So we come to the second question. How is the attitude of final users toward paying the green premium associated with green construction? Is it from Mr. Remir Yusef? Yeah.
It's a very good question as well. Once again, it's actually so that the society in Finland is very open to innovations. They are very concerned about global warming and about in our environment. So I'm sure that there is a quite a big willingness for the people in the society that um, green premium is part of our new builds, and it's part of the fees we have to pay. I think they are more willing to pay this than maybe taxes for other purposes. We are one of the countries with the highest taxes in the world, so people are used to pay extra for the further good, but society and people are open to that, and I think they see the necessity, and I hope this is something that we could see globally as well. I think it's the only way to promote green construction.
Yeah. Is it answer your question, Mr. Remir?
Yeah, it does. Thank you very much, Prof.
Okay. Okay,
You're
thank you.
welcome.
And then we come to the third question. And it's from Aditya P. Utomo. Yeah. And he's think that the use of special concrete becomes unattractive, yeah, due to its expensive manufacturing price and unusual materials in the market. So what do you think in Finland?
As well, this is a good question. I have to say, of course, we are. It's probably right to say they are more expensive. They are sometimes even not only double, but even 3 or 4 times more expensive. But I have learned one thing over my like career as a concrete expert so far, that we invest a lot of money in maintenance of our structures, in repair of our structures. We invest during the lifetime minimum, again, the investment we had to build the whole structure, we need to invest it again in repair and maintenance over the years. And at points where special concretes can help, that these repair costs are not high, are not so high, or the structures last longer, I think we can afford absolutely the investment costs for the material. Especially like in countries in Finland, the material costs are small compared to the labor costs, to the working hours, and to the costs to build structures. Salaries are pretty high in Finland compared to the material costs. So they are like investments in better materials is in balance with the general costs. So I think these special materials, they offer very good opportunities. The biggest problem is that owners or builders of the new structures, they need to make the investment costs in the beginning when they build it. And of course, this is hard for a problem that you might prevent only 20 or 30 years later. So, for instance, politicians never think like, I can save some money now, or I save some money in 30 years. They always would save it now. So we need to have then more awareness and more understanding for the common good investment, to rather pay now a little bit higher costs for better materials and then have no repair costs for later on.
Yeah. Yeah. Okay. Okay. I think this clear answer, Mr. Aditya P. Utomo. So I hope you can accept it. And then we come to the fourth question. This from Mr. Ibnus Shamsi. How to model the concrete propagation? Yeah. Actually, you have explained already, in the, but probably Mr. Shamsi needs little bit deep. Yeah.
Yes,
yeah.
I hope you can have time to read the paper. It's very well described there, how to model the propagation phase. It requires a model that describes the actual corrosion process and the cracking. There is very few models that allow that in the design phase. That means at that time we cannot yet measure on the concrete building like properties like concrete cover or resistance of the concrete, electrical resistivity, for instance, as a good indicator. We cannot do potential mapping. We have certain abilities on existing structures to measure the key parameters for the corrosion models. But in the design phase, when you have not yet built the structure, it's very difficult to estimate them. And there is very few models available. I have mentioned some in the paper, and they need to be used at that point in the design phase. But it's indeed not trivial, and we need a lot more research in that field and a lot better models for the future. I hope this answers your question.
Okay. We have only 2 minutes left, so I think this is the last question. The fifth question. This come from Surya Dewi Puspitasari. So probably you can have brief answer. Yeah. So how to determine the CO2 emission to the environmental impacts? Yeah. And then the second question, according to the model that you have developed, is it possible to use the model into reinforced concrete degradation based on visual inspections? This is the question from Surya Devi. Okay.
Thanks, Surya Devi. I answer the second question first. Based only on visual inspection, I think there is a simplified way to do it, but only if we have regular, frequent data from visual inspection from the same building. So when we see 1 year, okay, we have 2 cracks, and then we come 2 years later and we have already 5 cracks, and in 10 years later we have 500 cracks, then we might be able to prognose the way the cracking develops. But we will not have any better information on the actual corrosion procedure, and predicting the corrosion, we can only do that building a time series over many years. So it is one way to do it, but it's the most simplified way, and it's probably as well not the most accurate way. Then your first question, that's a very hard one to answer, because I think that is the biggest problem we have currently in this whole discussion on green concretes and how the emissions are based on the whole manufacturing and production chain. There's so many implications, but we have it's like turning into an own scientific approach in an own profession. Actually, nowadays we have plenty of colleagues, for instance, at VTT, at the institute I'm working, that do determine exactly these numbers for the whole processes. So not only for the materials and their manufacturing or production, but for the whole construction procedures. There is nowadays as well very good software supporting this. But if it's about new materials, you need to really go into the detail and determine these. So this is, of course, very, since it's so complex and you need so much data, it's very easy that one researcher comes to a different result than another one. We have not very good balance in that. On the other hand, there is already international standards that regulate how you actually determine these numbers. So LCA and LCA life cycle assessments and LCC life cycle cost assessments. So there is standards, and if we follow these, then we are within certain interpretation limit, and I think that's the way forward. I hope this answered your very good questions.
Okay. Yeah, I think this the time is past now. Now we are 2 minutes behind schedule. Okay, thank you very much for your presentation, and I will give brief summary for this discussion. So there is currently no clear alternative to structural concrete, but there is innovation and then need for alternative cement and concrete chemistries. And then we need for digital technologies And then finally, the service life design to utilize its full potential based on durability now and how. Yeah. Uh, Thank you very much, Prof. Pochner. This is very great presentation, and we are lucky to have you here. And do not surprise if in the near future we are from Civil Engineering University of Mataram. We will contact you to have some maybe discussion yeah, about this.
I'm
Okay,
happy
so
to stay in contact with you. Thank you very
yeah,
much for the possibility to speak at your conference. It was an honor.
yeah. So I hope you and good health. And once again, thank you very much for your presentation. And okay, time I give back to the MC. And before this, please everyone big applause to Professor. Once again, big applause to me. Thank you very much.
Okay, thank you. Thank you, Dr. Suryawan and Professor Fohner for the enlightenment from your keynote speech. Okay, ladies and gentlemen, now we are going to have a break until 12:30 at the most. So the parallel session will begin at exactly 12:30 p.m. So we are cordially invite you to go back again to this virtual room at 12:30. Have a nice day. Thank you and see you later.